Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own. So I'm really happy about this because I sat here for like a good hour and a half trying different approaches, almost solving it, but I finally broke through. So again, let me show you what I did. Yeah, again, just really happy that I solved this one without any help, and just shows you that perseverance is important. So let's go over it. So basically you're given an integer array nums, and you want to use binary search to find the perfect subarray size whereby they're strictly increasing. So through trial and error, I discovered this doesn't have to mean it's like 324, it could be 325, as long as it's increasing, as long as it's not like 225 or 335. It can't be increasing. So it doesn't have to follow exactly +1 or +2. So with that being said, let's go over it. So basically, I'll show you what I did. So first thought is to pre-compute the differences. So for I in range length nums to -1, let's call this pref. So what we're going to do is we're going to say, is the next one bigger than the current one? If it is, then it's good. If not, then it's bad, because we want to make sure it's increasing. So if nums of I is less than nums of I +1, then pref.append good, otherwise pref.append bad, and the last one will always be good. So let's print pref and nums. So now you can see good until we get here 0 1 2 3 4 0 1 2 3 4. So this one, there's a mismatch because this is actually supposed to be bigger than 9, but it's not. So we put bad. So we're actually going to say, like, if we want to make sure this subarray is good, we're going to check, or this subarray is good, we're going to check this. This subarray, we're just going to check 0 1 2. We're going to check 2 and 3. So 1 less than, not the whole thing. So that's how I did it. So now let's go ahead and define our binary search range. So again, we want to find two subarrays that are adjacent. So adjacent means, for example, I plus size, and the next one starts right at that point. So the binary search range is going to be 1 length of nums divided by 2, because there has to be at least 2 subarrays. And while left is less than or equal to right, this is going to be our size equals left plus right divided by 2. And then we're just going to try our size, right, to make sure that, because we want to find the maximum size that's possible. Okay, so now what we're going to do is we can do our sliding window now, right? So for I in range length nums minus size +1. So at the end, you know, if whatever condition is still true, then we're going to increase, because we want to find a better size, a bigger k value, otherwise it's not valid. And then we will just return an answer at the end, which is going to start at 0 because we're trying to maximize something, right? Okay, so now we have to make sure that, let's call this pref of I plus size -1. So in this case, right, there's no mismatch, they're all increasing. So if bad is not in now, then the flag is, or if it is in now, then flag is false. And let's do this as a flag for the current subarray. This is the overall one. So ff equals to false, otherwise ff equals to true. And if the flag is not empty, if it is true, then we know the subarray is not violated, so we can actually have a dictionary. And we don't even need a dictionary. We can just, well, we can just say d of I is equal to whatever you want, anything, because we don't care about that actual subarray itself. We just say, okay, this is a good point, starting point that we have. And then now what we're going to do is create a sorted set of d.keys, and we're just going to ask for, so if we have all of the valid points, for example, let's say 1, 4, 6, and size is 2, then 1 plus 3, this is also a valid one starting here, so that's going to be valid. So that's what we're looking for. We're looking for each value in A, if value plus size is inside of A, then flag is true. Okay, so flag starts as false because that's what we're going to do, and we're going to break. And then based on this, if flag is valid, then answer is max of answer and size, right? So size instead of mid. So this is technically going to work, but it's a bit slow because this is n by itself in addition to this. So you're going to get time limit exceeded. Cool. So what we're going to want to do is, we got the bulk of what we want to do. So instead of having to go through every single subarray and check, okay, if there's any violation, we've already pre-computed this right here. So that's what this was about. And this is just a binary search to find the size. So now instead of making a new subarray every single time, it's a bit tricky, but let's create a counter of pref of size -1. Let's print C. Okay, so we're going to want to make C reflect the frequency of now, so that we can say that, for example, 1G, 1B, and then we're just going to check here if the dictionary has at least a B inside of it bigger than 1, because we're going to delete the key if the frequency becomes 0. So let's print I and I plus size -1. So 0 and 1 is already covered. Now 1 and 3. So C of pref of I minus equal to 1, if this is the frequency, because we're seeing 1 less, we're shrinking the window from the left, is equal to 0, then delete that key value pair. C pref of I plus size -1 plus equal to 1. So we're adding the right, shrinking the left. So in this case, we started here, we want to go here, so we're getting rid of this and adding this guy. Okay, so I want to make sure this reflects. That's not correct. I think what I did was I put it here. So good. Okay, cool. So now we have our dictionary reflecting this subarray, and we can get rid of this, and we can just say if C of B, it is the key, then it has at least 1 frequency. So there is 1 violation, so the whole thing is bad. Let's run this and submit it. And there you go, passes all test cases. So again, this is not the most efficient solution, but I did come up with this on my own without any help. So I'm really proud of this. And yeah, so hopefully this makes sense to you guys. It's kind of a messy solution, but this again was just going through this sorted set and making sure that there's at least the current number plus size inside of it, basically meaning there's an adjacent array. So we saw a valid A, is there a valid B? Because K is the size, right? So value plus size is A plus K, and A is just the sorted set of the dictionary keys. So that's it for this video. Hopefully this wasn't too bad. Thank you for watching, and stay tuned for more.